So I'm going to answer why every translation in Etch-a-Sketch is an isometry. So first, in order to start this problem, it's important to start with definitions. So the definition of translation is given a distance and a direction. The image is the point that is the given direction from the original point in the given distance. So in simpler yet incorrect terms, translation means to slide an image over figuratively, not literally. And isometry is a transformation or function that preserves distance. And so why every translation in Etch-a-Sketch is an isometry can be proven through 6 steps. So first, since there are an infinite number of numbers, we must start with an abstract translation. And so our direction is going to be represented in X, and our distance is going to be, our distance is going to be represented with X, and our direction is going to be represented with Y. And so these two variables can be replaced with any number. And then step 2 is to fix 2 abstract pairs of points. And so again, you could plug in any numbers, but we can call point or pair number 1 AB and pair number 2 CD. And so our next is to name our images. And so we're going to draw our translation. So over X up Y, over X up Y. And we get 2 new points, which would be A plus X, B plus Y, and C plus X, and B plus Y. This is wrong, and this should be D. So that is my mistake. But like Brett said, you don't have to redo everything. So that is actually going to be D plus Y because you're adding X and you're adding Y when you translate your 2 points. And so that's naming those first images, these images. The 4th step is to find the distance of the original point. So you have to find this distance. And you can find that through the expression, not the equation, since these are variables, the expression of the absolute value of A minus C plus B minus D. And you use absolute values to avoid negatives, and you use addition because if you think about a triangle in Etch-a-Sketch, you're adding the length and the width to get this distance. And so that expression represents this distance. And so to prove that it's an isometry, you also have to find the distance of this. And ideally, if it's an isometry, it'll be the same. And so you just basically do the expression from up here using the points that we talked about here. And you do the same thing. And so this one is going to have a longer expression, but thanks to the distributive law, it simplifies down to that, which, as you may have noticed, is our same from up here. And so step number 6, since the 2 distances are equal, you have an isometry.